Circuits by Tichina and Cheyenne McBeam. What is a circuit, you may ask? A circuit is any complete path along which charge can flow.
There are two types of circuits, a parallel circuit and a series circuit. A parallel circuit is an electrical circuit in which devices are connected to the same 2 points of the circuit, so that a single device completes the circuit independently of the others. A series circuit uses only one path through which a current flows through one resistor.
For parallel circuits, the current is equal to the sum of the currents in the branches, whereas for a series circuit, the current stays the same throughout the entire circuit. The voltage in a parallel circuit stays the same across each resistor, while in a series circuit, the sum of the voltage drop across the resistor is equal to the total voltage drop. As far as resistance, in a series circuit, the equivalent resistance is equal to the sum of the individual resistors, while in a parallel circuit, the equivalent resistance is less than the value of any individual resistor.
Ohm's law is when a current in a circuit is directly proportional to the voltage and inversely proportional to the resistance of a circuit.
Current is the flow of charged particles. The symbol for current is I. The units for current is amps, but is abbreviated with an A. The equation for current is I equals V divided by R. In the next two slides, I will further explain what R and V are.
Resistor. The resistor is the resistance of material to the flow of electrical current through a circuit. The symbol for resistor is R. The units is ohm, and the equation is R equals V divided by I.
Voltage. Voltage is the potential difference in a circuit. The symbol for voltage is V. The units for voltage is also V. The equation for voltage is V equals I times R. Because the symbol and the units are both V, this should be much easier to remember.
Circuits can also be illustrated through diagrams. There are approximately 10 circuit diagrams. There is a conductor, a battery, a fixed resistor, a switch, a capacitor, a fuse, a ground, a lamp, a voltmeter, and an ammeter.
Now it's time for an example. For this example, you will be solving for the total resistance, the total current, voltage number 1, and current number 1. You will also be naming the type of circuit that is shown.
First, you should know that this is a parallel circuit. To solve for total resistance for a parallel circuit, you should use the equation total resistance equals 1 divided by R1 plus 1 divided by R2, all raised to the negative first power. Let's begin with substitution. Since R1 is 5 ohms and R2 is 20 ohm, the equation would be total resistance equals 1 divided by 5 plus 1 divided by 20, all raised to the negative first power. 1 divided by 5 plus 1 divided by 20 equals to 0.25. You would then raise 0.25 to the negative first power, and your final answer or total resistance would equal to 4 ohms.
Now we're going to solve for the total current. The equation used to solve for the total current is voltage divided by resistance. Since the total voltage is 40 volts, you would substitute 40 for voltage. And since the total resistance is 40 ohms, you would substitute 4 for the resistance. Your equation would be total current equals 40 divided by 4. Your final answer for total current should be 10 amps.
How to solve for voltage 1. To solve for voltage 1, you should use the loop rule. The loop rule is always used to determine the voltage in a parallel circuit. The loop rule is the voltage across each resistor. Because the total voltage is 40 volts, voltage 1 is also 40 volts.
How to solve for current 1. The equation used to solve for current 1 is voltage 1 divided by resistance 1. As in the previous slide, voltage 1 is 40 volts, so you would substitute 40 volts for voltage 1. Since resistance 1 is 5 ohms, you would substitute 5 ohms for resistance 1. Your final equation would be 40 volts divided by 5 ohms. Your final answer, or current 1, should be 8 amps.
Final answer. The total resistance is 4 ohms. The total current is 10 amps. Voltage 1 equals to 40 volts, and current 1 equals to 8 amps. And this was a parallel circuit.
And this concludes the presentation of circuits
by Cheyenne McBee
and Tichina Seiler.